In a hydronic heating distribution system, it's easy to focus on gallons per minute and feet of head, but one often overlooked yet critical factor that influences system performance, longevity, and comfort is water velocity. Simply put, velocity is how fast the water flows through the piping, measured in feet per second, FPS. Like many things in HVAC, water velocity is about balance. Too low and you get inefficiency. Too high and you risk damage. Welcome to Boiler Room Detective. I'm your host, Ray Wolfarth. The speed of water affects how efficiently heat is transferred from the boiler to the terminal units. If the water moves too slowly, it loses heat too quickly, especially in the long runs, and may not deliver enough warmth to the far zones. On the other hand, high velocity may not allow enough time for heat transfer in the radiators or heat exchangers, reducing comfort. Water moving too fast, typically above 4 feet per second in copper tubing, can cause turbulence and velocity noise, the rushing or whooshing sound you hear in piping. Even worse, high velocity can lead to erosion inside the pipes and fittings, especially at elbows or changes in direction, shortening the system's lifespan. High-velocity water can keep microscopic air bubbles suspended in the flow, making it harder for air separators to remove them. Entrained air reduces heat transfer, causes gurgling noises, and accelerates corrosion. Water velocity ties directly into pipe sizing and pump selection. Undersized piping or oversized pumps can result in excessively high velocity. Oversized piping or undersized pumps may produce sluggish flow, leading to cold spots or underperforming zones. Uneven flow due to poor velocity can lead to some zones overheating. Maintaining the proper velocity ensures even heat distribution and better system balancing. The recommended velocity guidelines are copper pipe use 2 to 4 feet per second, steel pipe up to 10 feet per second. A system design rule of thumb is 2 to 4 feet per second is ideal for comfort and longevity. PEX is typically 2 to 3 feet per second. What happens if the water velocity is below 2 feet per second? You get poor heat transfer. Water moves too slowly to effectively transfer heat from the boiler to the terminal units. Zones furthest from the boiler may be underheated, leading to customer complaints about cold areas. Heat exchangers may not perform efficiently, resulting in short cycling. At low velocities, small air bubbles tend to cling to the pipe walls instead of being swept along to the air separators. This leads to air pockets or air locking in terminal units, which reduces heating capacity and can cause gurgling noises. Poor air removal increases the risk of corrosion in the system. Flow may become laminar, smooth layered flow, rather than turbulent. Turbulent flow increases mixing and heat exchange, while laminar flow reduces system effectiveness, especially in heat exchangers and coils. Slow-moving water can allow dirt, rust, and other particulates to settle out in low spots like elbows, radiators, or heat exchangers. Over time, this causes flow restrictions, reduced heat transfer, and premature failure of the components. If heat isn't being effectively distributed, the return water stays warm. The boiler may cycle off prematurely, wear out controls, and operate inefficiently, increasing fuel consumption. With low velocity, thermal stratification can occur in storage or buffer tanks. Hot water stays at the top, cold at the bottom, preventing proper blending and consistent temperatures. What are the problems you get with high velocity? High velocity water creates turbulent flow which results in whooshing, rattling, and knocking sounds, especially near fittings, valves, or small diameter pipe. Sudden changes in direction or pressure can cause water hammer, which damages pipes and annoys building occupants. Fast-moving water, especially in copper or brass piping, can gradually erode the inner walls of the elbows, T's, and valves. Over time, this leads to pinhole leaks, premature pipe failures, and costly repairs. In certain cases, high velocity can reduce pressure at the pump suction enough to cause cavitation, the formation and collapse of vapor bubbles that can destroy pump impellers and create loud banging or grinding noises. Higher flow equals more friction equals greater pressure loss across the system. This can make balancing difficult, lead to undersupplied zones, and force the pump to work harder, shortening its lifespan and increasing electrical costs. High-velocity water acts like sandpaper over time. It can damage pump seals, control valves, thermostatic mixing valves, zone valves, and flow meters, all expensive to replace. Many balancing valves and flow sensors are calibrated for moderate velocities. High velocity can lead to false readings, making it harder to properly balance the system. Thanks for stopping by Boiler Room Detective. Please like and subscribe to the channel if you find the video educational. My boiler books are available at Pronto Heating Supplies in New York and on Amazon.com. My articles are found on many of the industry magazine sites. I appreciate any comments, and I'll see you on the next case.